We have several methods for the preparation of salt. So we have divided our this lecture in several parts. So in part 1 we will deal with the preparation of water soluble salts by the action of acids on metals. This method can only be used with the moderately reactive metals. It would be very dangerous to use a reactive metal such as sodium or potassium in this type of reaction. The metals usually used in this method of salt preparation are magnesium, aluminum, zinc, iron, and tin. So in short, we can remember these the term mazit. You can see in this diagram a, a magnesium ribbon is there in the solution of hydrochloric acid. You can see the bubble over there because this reaction produces hydrogen gas. So this hydrogen gas can be seen in the form of bubbles. So for the typical experimental method, we need following steps. Number 1, excess of magnesium ribbon is added to dilute hydrochloric acid because the unreacted magnesium can easily be removed by filtration method. During this addition, an effervescence is observed due to the production of hydrogen gas. So the production of hydrogen gas that can be seen here. In this reaction, the hydrogen ions from the acid gain electrons from the metal atom. So metal is providing electron to hydrogen ions so that hydrogen ions are being reduced from H plus to H2 gas, H2 molecule. So this is the reduction reaction. And magnesium or any metal if we use, it is being oxidized because metals are best electron donor. So metals donate its electron to the hydrogen ions. In this way, this redox reaction can be accomplished. So you can see here the first step is the reduction and the second is the oxidation. Then overall reaction is called a redox reaction. Here this diagram that you have seen in previous slide, it is given here again. So you can see that we have taken the sulfuric we can take in hydrochloric acid in the test tube, then we have added magnesium ribbon into the test tube, and this magnesium is in excess. That's why you will see after some time the effervescence will stop. The stop of effervescence means the reaction has been completed and all the acid has been consumed. So in this way, when we then we are sure that there is no excess of acid, so we can perform filtration so that we can remove this insoluble metal. Remember that all the metals are insoluble in water. So here metal would remain as residue on the filter paper while filtrate comes into the evaporating dish, and this filtrate contains magnesium and chloride ions in our case. So as there is water, we have to remove this water to get crystals of magnesium chloride. So we perform evaporation. This evaporation can be carried out either directly on flame or by indirectly, as given in this method, that we have taken a beaker full of water. So on heating, water will be converted into a steam. That steam will heat the evaporating dish gently so that our crystallization process can be achieved perfectly. So as evaporation is going on, then after that we can get the saturated solution, and from that saturated solution, when we perform the cooling process, then we can get the crystals of magnesium chloride in this evaporating dish that will be separated from their solution. So after filtration, again we can get the pure crystals of magnesium chloride from there.